to honorable
Good
guests,
evening, ma'am.
respected dignitaries, and dear participants. I am Dr. Indira Dixit. Welcome you to all on seventh day of training program on first-hand experience on SPSS Introductory module organized by Research Foundation of India RFI-CARE in association with Faculty of Commerce, Parul University, Gujarat, Bhagwan Parshuram Institute of Technology, Delhi, sponsored by Eklavya University, Damoh, JHERF World Virtual Conference, Forum World Federation of Science and Technology, International Research Guide Federation, Academic Research Guide Association, EDU, Academic INC. Uh, Today is the last day of the lecture series, and dear participants, we are happy to have with us our star guest of honor, Pure Heart Lady, and the miracle genre of this series on the depends on Chanchala Madam, today's expert. I invite to you, ma'am, and welcome to you.
Thank you so much, Indra ma'am, for your kind words. Thank you so much.
Ma'am, I request to you, please start today's session.
Okay. Thank you so much, ma'am. Yes. So good evening, everyone. As Indra ma'am has already informed us that today is the last day of this FDP. So today I'm going to take regression and correlation, right? So
Good evening, ma'am.
yes, very good evening.
Good
So
evening, ma'am.
yeah, just a minute, give me 2 seconds. Yes, so I'm back. Extremely sorry for the interruption. So today, as I said, today we are at the last day of this FDP, and I'm going to discuss today correlation and regression, right? So give me a second. Firstly, I'm going to share my screen. Yes, I have shared my screen. Anyone, will you please confirm me whether the screen is visible or not?
Yes, ma'am, visible.
Yes, thank you so much, everyone. Yes, so today the agenda is I'm going to discuss firstly the correlation, its types I'll discuss, then I'll discuss the assumptions of correlation, and then we will see regression and its assumptions. So firstly, I'll discuss correlation, then we will go to the SPSS and we'll see how we can apply correlation, and then I'll talk about regression and its application or its implementation through SPSS, right? So firstly, the correlation. Correlation is a very important statistical tool in statistics because it is generally known as the building block. Building block means for many further advanced statistical tests, generally we need to know the correlation or the relationship between the variables. So that way we can say correlation is a statistical tool which helps us to find the relationship between the two variables. So that relationship helps us to further decide whether we need to go for the advanced testing or not. So that is why this particular test is known as the building block. So it is like if as we have already seen median standard deviation previously, and we are knowing generally in the descriptive statistics we are finding mean and standard deviation. Similarly, these particular values helps us out to find further statistical tests. Similarly, the correlation also works. It helps us to firstly understand the relationship between the variables, and then further we'll decide upon which statistical test we can apply after understanding the type of relationship we are having between the variables, right? Further, in other way around, if I say that correlation is helps us to find the extent of relationship between the variables, means up to what extent two variables are related to each other, we must know this thing. right? So that way we can say the correlation will help us to find the strength of relationship between the variable. That is, what is the strength or up to what degree two variables are related to each other. So now, the one important thing you can see here, that word I have taken in the red color, it is indicating in linear relationship, right? So correlation helps us to find linear relationship between the two variables, means whether the two variables are linearly related to each other or not. So the meaning of linear is, if we are increasing one unit in one variable, other variable is increasing in the same proportion. So that way we can call it as a linear relationship. So one example you can see here, generally being a academician, generally I quote this example, that if we want to see the that whether means if a student is putting so much effort in his or her study, so that way we are knowing this thing, that student learning would be better, right? So that way we can say it is a kind of positive correlation between these two variables. Now, talking about the types of correlation, so we can bifurcate correlation broadly into the two categories, the positive correlation and negative correlation. But those who are from the statistics field, they know that there are some other types of correlation also available in statistics. But broadly, we need to know these two important correlation, that is positive and negative correlation. So positive correlation means when we are increasing one variable, other variable also increases, or when we decreasing one variable, other variable also decreases. So that way this is known as the positive correlation. So we can say, looking at this particular graph, you can say this is the interpretation, or this is the graphical representation of the data, which is indicating that there is positive correlation between the two variables when we are keeping one variable on x-axis and other variable on y-axis. And if we are plotting the data on a graph, and if we are getting this type of representation of the data, so that way we can say that we are fitting a line. So this line is upward line, right? So this line is indicating that there is a positive correlation. The direction of the relationship is upward. So it is known as the positive correlation between the two variables. Now, when we talk about negative correlation, so negative correlation means when the direction of the change is different, means when I'm increasing one variable, other variable is decreasing. So that way this is known as the negative correlation. So you can see, using the graph, we can understand if we are plotting the observations on a graph, and if we are getting this type of graph, and if we are putting a straight line between these points, so we can understand this is a downward line. It is indicating that there is a negative relationship. Means if I'm increasing x, y is decreasing. So that way this is known as the negative correlation. Examples I have taken here to understand positive and negative correlation. Now, one way of it means it might be possible if we are plotting the data on a graph, and sometime it is showing us such kind of distribution of the data. So again, it is indicating that there is no relationship between the variables. So that means these are scattered here and there, but they are not going in particular direction, right? So this way, this is known as the no correlation between the variables. Now, using these arrows, we can again understand that if I'm increasing x, y also increases. If I'm decreasing x, y also decreases. So this is known as the positive correlation. Means when the change of direction is same, it is known as positive correlation. But when the change of direction is opposite, if I'm increasing x, y decreases. If I'm decreasing x, y increases. So it is known as the negative correlation between the variables. Now, talking about how we can measure the correlation, right? So to measure the correlation, there is the statistician with the name Carl Pearson. So the Sir Carl Pearson has given a coefficient. So using the coefficient, we can measure the correlation between the variables. This is generally known as coefficient of correlation. So this coefficient of correlation indicates the strength of relationship between the variables. So it is a standardized number which represent strength of relationship between the two variables. So I think rather than saying its number, we can call this is not a number. This would be some value in the fraction point or in a percent form, right? So that means the values generally when I'll discuss about the values of this coefficient of correlation, so I'll discuss that what is can be the maximum and minimum value of correlation. So it is the important thing you need to know. At the table you can see, if I talk about the values of correlation. So if we are, suppose we are having two variables, we are having the data for two variables. And if we are calculating correlation and the value of correlation, that is small r, we represent correlation with the small r. So if we are getting a small r value as 0, it indicates that there is no correlation existing between the variables. But when the R value lies in between 0 to zero point 0.3, so the sign can be plus minus, because correlation can be negative also, as we have just discussed that positive and negative correlation, right? So it can be minus zero point 0.3 also, right? So in that case, it is known as low correlation. In case of positive sign, this is positive low correlation. In case of negative sign, it is a negative correlation. Now, if R lies in between zero point 0.3 to zero point 0.5, we can call it as a moderate or the average correlation between the variables. When the value of R lies in between 0.5 to 0.7, we can call it as a above average correlation. In between 0.7 to 0.9, we can call it as a high correlation, right? When the value of R is greater than 0.9, we can say that there is a multicollinearity. If you can recall the previous sessions, when I was discussing about the Norventian reliability, I have indicated you this particular terminology, that when you are getting the coefficient of correlation more than zero point 0.9, that is the indication that there is a multicollinearity in the data. But usually when you are having two variables, and if the variables are almost similar, so chances you can get the value of R even greater than 0.9 also, right?
Yes, ma'am.
Okay. So I hope I am clear till this particular slide. Any doubts so far? May I proceed?
Yes, madam.
Yes,
Yes, thank you. Coming to the type of variables versus type of correlation. So generally, according to the nature of the variable, that means on what scale you have measured your variable, we decide upon which correlation we need to apply, right? So here, if your variable means x and y, x is generally indicated as a, give me a second, just a minute.
I'm not getting any voice. Ma'am, please. Am I audible?
Hello.
Yes, ma'am.
Sorry, I was busy. There was someone, actually, I am in college only. So,
Okay. Okay.
yeah,
No problem.
so extremely sorry for the disturbance. Yes. So, I'm
No.
continuing with the types of variables versus type of correlation, right? So, here we need to understand this thing, which type of correlation we are going to apply, that we need to decide upon the nature of the variables. So say for example, if we are having two variables x and y, so here you can see generally in maths we know x is the variable which is known as the independent variable and y is the variable which we know as the dependent variable. But I need to make you clear this thing. Generally in case of correlation, we do not differentiate variable in terms of dependent and independent, because the correlation will not help you out to understand which variable is dependent and which variable is independent, right? So you need to only say this thing that we are having two variables. If both the variables are the continuous variable, in that case we can apply this Pearson's coefficient of correlation. Then if your one variable is ordinal, second variable is continuous variable, in that case we can call that we need to go for the biserial correlation. Similarly, for the nominal scale variable and continuous scale variable, we will go for the point biserial correlation. Then for the ordinal and ordinal, means both the variable are on ordinal scale, in that case we can go for the Spearman rank correlation. And if both the variables are on the nominal scale, we will go for the coefficient of phi or lambda. So this way, these are the various types of correlation available in statistics which we can apply on the variables, this according to their natures, or according to on which scale we have measured on our variables, right? Proceeding further, talking about the assumptions of correlation. So generally, the first assumption is your variables should be quantitative. Whatever variable we are taking, may be possible in future we want to use one variable is dependent, other variable is independent. But whatever two variables we are considering for the correlation, they should be quantitative. That is, they should be measured on interval or on the ratio scale. So here I need to clear this thing. Let me clear this thing, that you need to understand this thing. Here I am going to discuss only the coefficient of correlation. Sorry, only the Karl Pearson's coefficient of correlation. So the Karl Pearson's coefficient of correlation is the statistical test which considers the two quantitative variables, which are either on the interval scale or on the ratio scale. Second assumption is x and y should be linearly related. So we need to check this thing. We can use the scatter plot or something. With that we can check whether the two variables which we are considering, whether they are linearly correlated or not. Then you need to check absence of outliers. So there should be no outliers available in your variable. So again, if you are deciding by your own that one variable you are going to take as a dependent and other you are going to take as an independent variable, so that you need to see which variable you are taking as dependent variable. For that variable, you need to check the outliers, right? Similarly, for the normality, so whatever variable you are going to take as a dependent variable, that variable you need to for that variable you need to check the normality of the variable, right? So this way, these are the assumptions of correlation. One more assumption which I have found in the literature, it is about the sample size. So at least for the minimum 30 observations, we can generally apply the correlation, because the condition we know according to the central limit theorem, usually when the sample size is 30 or more, generally in that case we can say this thing, that the variable is approximately normally distributed. So generally for that purpose we can say that observation should be minimum 30. So this way, these are the assumptions which we need to check before applying the correlation, right? Now, talking about the importance of correlation. So generally, it explains us the variability, that is variance in the data, but it will not the causation, means it will not help us to find whether or measure that causation is there in the variables or not. So we can say that this thing, that the correlation capacity is not to tell us the cause and effect relationship between the variables. For the purpose, we are having the other test that will tell us which variable is cause variable and which variable is your effect variable. Now, talking about, if I talk about the numeric calculation or the manual calculation of the coefficient of correlation, you can find these are the various formulae available. Using them, we can calculate the small r figure. So depending upon, for manual calculation, depending upon what type of data is given or in which form data is given, accordingly we can decide upon a formula to calculate the value of r, small r, right? Then talking about in this table, you can see we are having two series X and Y, or two data sets X and Y. So using, suppose this first formula I'm talking about. So for this particular formula, you need to calculate these three things, and then we can put all these three things in the formula to get the value of R, right? Further, what steps you need to perform to apply correlation using SPSS, you can find these are the various steps we need to perform. So this is about the conceptual aspect of correlation. So any doubts so far? Yes.
No, ma'am.
Okay. So now we will proceed with the SPSS, and I expect everyone to open the employee data set, which I have already shared with all of you. I expect all of you to open the same data set. How many of you are performing along with me? Yes.
So I'm still listening to your lecture.
So no one is
I cannot
performing? I think one or
Ma'am?
two. Yes.
Performing, madam.
Performing. Okay. That's good. Okay. So give me a second. Again, I'm sharing my screen with all of you, I think. Yes. So you need employee data set. Everyone has opened, those who are performing along with me. So here, firstly, as I said, I'm going to discuss the Karl-Pearson's coefficient of correlation, which is requiring the two variables on the numeric scale or on the continuous scale. So I expect everyone here, there are two variables with the name salary and salary beginning, or the beginning salary, right? So with the help of these two data or these two columns, we will perform correlation first, right? Everyone is fine with this? Got it? May I proceed? Okay. Any confirmation?
Yes, madam, following.
Okay. Thank you. So now you can see here I have written correlation for the purpose, as I want you to tell me if I am taking two variables, salary and the beginning salary, that is current salary and the beginning salary. So how I can formulate my hypothesis? Anyone? Yes.
There is no correlation between the two salaries, ma'am.
Okay. So we can write there is no significant relationship between current salary and beginning salary. Is it fine? Formulation is clear for hypothesis?
Yes, ma'am.
Yes. So this would be our null hypothesis, and similarly we can create alternate hypothesis that there is a significant relationship between current salary and the beginning salary, right? Now we will proceed further, and here we will check. If I talk about current salary and beginning salary, so I think scale is quite clear. These are the numeric scale variables, right? So that means we have checked first assumption that both the variables are on quantitative in nature, or both the variables are on numeric scale. Is it fine? First assumption is clear. May I proceed with the second?
Yes, ma'am.
Yes. So if it is clear, now next we need to check. Okay, so next we need to check the outliers in the variable. So before deciding that, if suppose if I want to go for the further analysis, right? And we are having two variables, current salary and beginning salary. So can anyone tell me which variable I can take as a dependent variable and which variable I can take as an independent variable? Yes, which variables?
Salary is dependent variable.
Okay.
Independent variable.
Beginning salary.
Anything you can
Sorry.
Job category, or we can take this, what's it, initial beginning salary, something like that.
Ma'am, actually, we have formulated the hypothesis and we have two variables, current salary and beginning salary, right? So as you said, salary, that is current salary, it is right. We can take current salary as our dependent variable, and
Okay,
the
then its beginning salary will be the independent.
independent variable, right? So yes, you have understand it correctly, right? So again, I'll repeat. We will take current salary, that is salary, as our dependent variable, and beginning salary as our independent variable, right? Now, if we have decided this thing, so we need to check for the salary that whether the salary is normally distributed or not, and whether there is any outlier available in the salary or not, right? So for checking that, I think now you people are well versed with the procedure. You need to go to the descriptive statistics, then you can go to the explore option, and then in the explore you can shift your current salary to the dependent list box. Then you can click on the plots, you can deselect stem and leaf, and you can select the histogram, and then next you can select the normality plots with test. Then you can press continue, then you can press OK, and that way you will get the output for the current salary. And here you can check everything. You can see the mean value, median value. So there is a difference in mean and median. So that will probably we can say that the salary is not approximately normally distributed, or salary is not normally distributed. Similarly, looking at the kurtosis and skewness value, it is again a little tough to say that salary is normally distributed. Coming to the next table, test of normality, that is Shapiro-Wilks test. Here you can find the significant value is 0.000, so which is less than 0.05. So that means we are not going to accept the null hypothesis of the Shapiro-Wilks test. So can anyone help me out? If we are not accepting the null hypothesis of Shapiro-Wilks test, what we will conclude?
The variables are not
Data is
normally
not
distributed.
Very correct. Very good. Thank you, ma'am. So the answer is very correct. We can conclude this thing here that the variable current salary is not normally distributed. Very correct. Going down, looking at the histogram for the current salary, it is again saying us the same story that the salary is positively skewed here, right? Talking about the QQ plot. So QQ plot is again showing us that the salary is not normally distributed. Going down, talking about the outliers, we can find here there are many outliers available in the salary variable. Is it fine, everyone? With interpretation part is clear to everyone?
Yes, ma'am.
Yes. Now further, we will see this thing that how we can, although we are violating this particular assumption has violated, means two assumptions of main assumptions of correlation have violated by our data, but still for the sake of demo, I'm telling you how you can perform correlation using the SPSS. So for the purpose, you need to go to the analyze menu, then you can go to the correlate. Again, I'll repeat, go to the analyze menu, then go to the correlate, and from here you need to select bivariate. I hope everyone has located these three things here: analyze, correlate, and bivariate. May I click on bivariate?
Yeah.
Okay. So now you can see once I have clicked on the bivariate, we are here with the bivariate correlation dialog box. Here I am expecting all of you to shift your both the variables, current salary and the beginning salary, using this arrow key to the variables box like this. Is it fine? May I proceed?
Yes, ma'am.
Yes. So now further what you need to do after shifting your variables, you need to check here. There are some options there are some buttons are coming. You can click on the first button, options button, And here you do not need to touch anything. It is asking you mean and standard deviation. If you want to calculate for your variable, that you can check here. If you want to find cross product deviation and covariances for your data, for the purpose you can select this. But again, here we want to see only the correlation value, so we will go with the continue option. Then further you need to come back to the same box and you need to check at the below. You can find correlation coefficients option is given, and here we are given with the 3 check boxes. First is for Pearson, then Kendall's, Taubes, and then Spearman. So SPSS will help you out to find these 3 types of correlation in the variables, right? So here we have taken 2 variables which are on the numeric scale, or these are the quantitative variables. So according to the nature of variables, suggestive one is Pearson's, and by default it is checked by SPSS. So we will go with the by default option. But if you will have the ordinal scale data, in that case you can go for the Spearman rank also. Similarly, for the nominal scale, you can go for the Kendall's Taubes also, right? Then coming to the next section, test of significance. It is talking about whether we want to apply correlation for the two-tailed test or as a one-tailed test. So here by default two-tailed is selected by SPSS. So I am okay with the two-tailed test, as we have made our hypothesis that there is no significant relationship between the current salary and the beginning salary. So that is why I will go with this particular option. Then it is at the end, it is showing flagged significant correlations. So meaning of this is that whatever is the significant values we are getting, they would be flagged. Flagged means asterisk sign, that is star sign, would be there from the help by the SPSS on that particular figures, right? So this is the meaning of this particular box. Now further to generate output, you need to click on OK button. So once I'll click on OK button, we would be able to get the output. In the output window, it is showing us the correlation between the current and the beginning salary. So you can see here, if we will find the correlation between the same variable, current salary and current salary, always this will come as 1. And 1 meaning is it is a perfect correlation between the 2 variables, right? So it is perfect positive correlation. Now coming to the current salary and the beginning salary, you can find the correlation is coming as 0.880, and it is you can find double asterisk sign is there. So double asterisk, as I said, flagged value. So if it is significant, we will get a flag, or we will get a asterisk sign. So double asterisk meaning is at 1% level of significance, this particular correlation is significant between the 2 variables, right? So significant value, that is P, it is 0.000, which is less than 0.05. That means we will not accept the null hypothesis, and we can conclude that there is a significant relationship between the current salary and the beginning salary, right? So this would be the interpretation of the correlation. Any doubt in this? Anything you want to ask me in this? Yes. Yes. Any doubt?
No, ma'am.
Okay, thank you. So this is about the correlation from my side. Now we will move to the regression. So now again I have shared my PPTs with all of you. Any one of you, will you confirm me whether the PPTs are visible or not?
Visible, man.
Yes, thank you. Going to the next part of the session. Now I'll discuss about the regression. So as I have in the previous half of the session, I talked about the correlation. I have told you this thing, that when we talk about correlation not at all help us to find the cause and effect relationship between the variables. Whereas when we talk about regression will help us to find cause and effect relationship between the variables. So that means correlation will only help us to find strength and the direction of the relationship, whereas regression will help us to find cause and effect relationship between the variables. Means which variable is causing change in the other variable, and which variable is showing the effect of that change. So that way we can say cause and effect relationship we can measure using the regression, right? So beginning of cause and effect relationship starts with the linear regression. As those who are good in statistics, those who have studied statistics, those who have applied various types of statistical tool, they are knowing this thing that in regression there are various types available. So today I'll talk about the very basic type, that is the linear regression, simple linear regression, right? So here you need to understand this thing, that whenever we talk about regression, so the starting of regression is with the help of this simple linear regression. So linear regression meaning is that we are it will help us to establish the cause and effect relationship when we presume two variables are linearly related to each other. And if you can recall yesterday's session, in that I have told you this thing, and I think in the slides also we have discussed this thing, that ANOVA usually comes as a output, as one of the table of the output of the regression, right? So meaning of ANOVA in case of regression is that it helps us to find whether the linear relationship is existing between the variables or not, right? So that way we ascertain this thing, that variables are linearly related to each other. Is it fine, everyone?
Ma'am, can you please explain once again how ANOVA is related?
As I said, when we apply regression using SPSS, in the output we will get one table for ANOVA also. So ANOVA will help us to see this thing, whether there is linear relationship available between the variables or not. So meaning is that the significant value of ANOVA should always be less than 0.05 if you have fixed the level of significance as 5%, right? So you will always check whatever level of significance you have fixed, whether your significant value is coming less than to that or not. So if it is coming less than to the level of significance value, in that case you can communicate this thing, or you can conclude this thing, that there is a linear relationship existing between the variables. Is it fine, ma'am? Or do I need to repeat it again?
Yes, ma'am.
Yes, for clear, or do I need to repeat it again?
It's clear, ma'am.
Okay, fine. So now this is about the first slide. Coming to the next, it is telling us if we can quantify for every unit increase in the independent variable, what would be the increase or decrease in the dependent variable, then we get the linear relationship between the two variables. So the meaning is very simple. If I am increasing one variable with certain unit, and the same proportion I am observing in the other variable, so that way it is indicating a linear relationship between the variables. Always you will get either the upward line or either the downward line when you are plotting a graph between the two variables, in case of understanding the linear relationship between the variables, right? Next point, we can use linear regression when we are interested to study the effect of one independent variable on dependent variable, right? So means when I talk about simple linear regression, we are always interested to find the effect of one independent or impact of one independent variable on one dependent variable. So meaning is we will always have one independent and one dependent variable in case of simple linear regression. But if we are having more than one independent variables, so in that case, this would be the case of multiple regression. In case of, again, I'll repeat, in case of simple linear regression, we will always have one independent and one dependent variable. But in case of multiple regression, we will have more than one independent variables. Talking about the hypothesis, so now when I'll go to the SPSS and I'll explain you, give you the demo of regression. So there I'll discuss about the advertisement and sales example. So with the help of this, I'll explain you that how you can perform regression, right? So for the purpose, I have taken the hypothesis in the form of advertisement and sales only. So here you can see we can formulate our null hypothesis in case of regression as advertisement is not related to sales, or we can say there is no significant relationship between the advertisement and the sales, or one more other way we can write it like there is no significant effect of advertisement on sales, and we can write there is no significant influence of advertisement on sales. So that way there are various types of ways to create your or to make your null hypothesis for the regression. So generally, whenever we are talking about effect, impact, influence, generally it is indicating we are trying to apply the regression in the given data, right? So before proceeding to the next slide, here I want to ask everyone that there are two variables I have taken clearly mentioned, advertisement and the sales. So can anyone tell me here which variable would be my cause variable and which variable would be my effect variable?
Madam, advertisement is an independent variable. Sales is a dependent variable.
Okay, very good. Advertisement would be my independent variable. Sales would be my dependent variable. So I can say advertisement can be the cause and sales would be the effect variable, right? So advertisement is causing change in the sales. So usually we are knowing that nowadays, as this is a very competitive era we are going through, and we are looking when I mean actually I'm very fond of watching TV, right? I usually watch various kind of movies, and some many a times in my leisure time I usually watch movies. And during watching the movies I have observed that I think it is not like me only who observed the thing. Maybe you people have also observed that there are various advertisement coming during the movies also, means because there would be certain breaks in the movies, right? So during those breaks, we have observed this thing that there are various advertisements of different types of products we can see. So the purpose of those advertisement is what? Generally, they want to create awareness about the product, right? So means the manufacturer or the company which is making such kind of products, they want to create awareness among the customers, and they also want to tell us to the customers that what type of or what are the main features of the product, right? So that way they try to allure the customers to buy that particular product. So it is quite obvious that somewhere they are interested or they are investing heavily in the advertisement because they want to increase their sales, right? So we are means we can say this thing that it is very clear or direct to understand this thing that somewhere advertisement investment play important role to boost or to increase the sales of any particular organization or any particular company, right? So that way this is a very classic example to understand regression. Now further talking about regression. So when I talk about regression and its assumptions, so there are total 8 assumptions. First one is both variables should be measured at continuous level. Means either we are having dependent variable or independent variable. Those variables should be quantitative, that is numeric, or they should be measured on interval or ratio scale. Then talking about next assumption. The next one is there needs to be a linear relationship between the two variables. So you need to check whether the two variables are linearly related or not. Next one is there should be no significant outliers. So you can write there should be no significant outliers in the dependent variable, right? Now, next is the residuals of the regression should follow the normal distribution that we can check using the normal PP plot. Then there should be absence of multicollinearity that we can check using the VIF, right? Next is the values of residuals should be independent that we can check using the Darwin-Watson figure. Then the residuals need to show homoscedasticity or the homogeneity of variances or equality of variances that we can check using the scatter plot. And lastly, there are no influential cases biasing your model. Means there should be no influential cases which is impacting whatever model you are making through the regression. So that you can check using the Cook's distance value. Now talking about the term residual, because you can see here in this particular assumption, Many of the times I have read this particular word residual. So you need to firstly understand what is the meaning of residuals. So generally residuals is what? Because as I said, using the regression, we are trying to fit a model. So as in case of simple linear regression, the model or the line which we are fitting between the variables, the equation of that is y equals to a plus bx plus epsilon. Epsilon is the residual or the error term. And now what is this epsilon? So generally, with the help of, because say for example which I have taken, advertisement and sales. So using advertisement and sales data of the past years, I have fitted a regression line between these two variables. Now I want to do the forecasting for the sales for the company. So I need to tell how much investment I'm going to do in the advertisement. So that way I can put that figure in the line, and I can predict the value of sales, right? That would be the predicted value of the sales. Now what is the actual value of the sales? So for example, for the month of suppose August, I have done the prediction of the sales, right? Now when actually the August will come and the company will see what is the sales figures, so that way we can compare what was the actual figure in the month of August and what we have predicted using the regression. So we can compare these two. So that way I can say the difference between the expected and actual will known as the residual or will known as the error. So this is the fitted line you can find here. This is the straight line you can find. This is the fitted line, and these are the residuals fine. So we are finding here what is the distance between this, whatever I am fitting, and this is the fitted, and these are the actual figures, right? So this is indicating the distance. So this way these are different. These difference are the these different things which you are looking here. These different lines which are going here and there. These are the error terms, right? So this way this is known as the residual. So now a good model is that in which the error term is very less, means your prediction is very close to your actual figure. So that way it is quite clear the model will be good. Means if my model is enough capable to say this thing, that the figure that the sales of the company would be this, and suppose actual figure of the sales are very nearby to what I have predicted, so that way we can say your model is a good model, right? Your model is a strong model. So that way it is known as regression. Talking about the homoscedasticity of the data. So if you're getting this type of scatter plot between your data, so this is indicating equality of variances. But if your data is forming particular type of shape of cone or fan, something type of shape you are getting in your data, it is indicating you heteroscedasticity in the data. And this way generally you need to your data should show the left type of graph. It should not show the right type of graph. So that way it is, if your data is showing right side of graph, it is violating one of the assumptions of the regression, right? So to make you clear more, I have taken one more graph here. You can find here if your data is showing such kind of distribution, right? So this is heteroscedastic data, left side this time, right? So here right side is okay. If your data should show the right side of graph, right, to meet the one of the assumptions of regression. Now what I have talked about the regression line. So I think we all have studied the straight line in our school time, and the equation for the straight line is y equals a plus bx, right? So here y is your dependent variable, a and b are your constant figures. So generally, technically or mathematically, we can call a is the intercept, b is the slope, and x is our independent variable. And this is what I had just spoken about this. This is the e, that is the error term, or this is your residual figure, right? So that way we make this particular straight line. So whatever value we are keeping here of a and b, because these are the two constant figures which we will get when we will apply the regression. If suppose some value I will put here for x, I can easily predict my y, right? So this way, this is the regression. Any doubts so far in regression? Or we can go for that application or applying of regression using SPSS. Any doubt in this?
No, ma'am.
Okay. So I think today I forgot to share a sheet with all of you. Give me a second. I need to stop share my screen firstly. Give me a second. I'm stop sharing my screen and I'll firstly share you through the WhatsApp the file and then we will apply this. Okay. I need to go to the SPSS. Yes. I have shared the file with all of you in the WhatsApp group with the name advertisement sales, right? Everyone of you are expected to download the same file so that we can work on the same. Okay, I have shared already. You people have found it? Yes?
Yes, ma'am. Yes, ma'am.
Yes. Thank
Yes,
you,
ma'am.
Sushma ma'am. Thank you. So now I expect every one of you to please open the file with the name advertisement and sales, right? Done? Shall I? Yes. May I proceed? Any confirmation?
Yes,
Yes,
ma'am.
madam, we are ready.
Okay. Thank you, sir. Thank you, ma'am. So now you can see here we are having two variables available, advertisement and sales. Firstly, we will formulate our hypothesis. So here I am writing the hypothesis. If any one of you want to try, what would be the hypothesis? Yes? Anyone?
There is no any significant relationship between sales and advertisement.
Okay, very good. Thank you. We can write there is no significant impact of advertisement on sales. Give me a second. Huh? I will resume. Give me a second. Uh, Again, apologize because I'm taking today's session from the college, right? Yes. So where were we? Screen is visible to everyone, right? Is it visible?
Yes, ma'am.
Yes. So now, firstly, as I have already told you, this way we can formulate the hypothesis. We want to see the influence of advertisement on sales. We want to see the impact of advertisement on sales. So we have formulated our hypothesis, and I think Prema ma'am, or I don't know who has given the answer. So we have confirmed this thing also, that advertisement we are taking as an independent variable and sales we are taking as a dependent variable, right? Now, further, we need to check assumptions of these regression. So some assumptions we can check in the output of regression only, but some assumptions we need to check priorly, right? So this sales data is different, which I have given you in the employment data or employee data. So for the purpose, this sales would be the different data. And as I have already told that we are going to take sales as a dependent variable. So firstly, we need to check outlier and normality for the sales variable, right? So I think now you people are knowing you need to go to the analyze descriptive statistics, and then you need to go to the explore. Here you need to shift your sales variable to the dependent list. Then you can click on the plots button, and then deselect stem and leaf, select histogram, select normality plots with tests, then press continue, then press OK to generate the output, right? Output window is visible to everyone, or yes, output window is visible.
Yes, ma'am. It is.
Yes. Yes. Now you can check here in the first section, case processing, it is indicating we are having total 30 observations. There is no missing value, and whatever is the 30 valid cases, that is why it is becoming the total cases, as there is no missing value available. Coming down, talking about the average sales, it is 10.08. 95% confidence interval of the sales is indicating 9.30 and 10.86. 5% trimmed mean is indicating 10.16. Then coming down, median sales is around 10.73. So you can find this mean and median are very close. So somewhere, I think looking at these two figures, we can conclude that sales is approximately normally distributed. Then variance and standard deviation of sales, minimum sales, maximum sales, range is difference of maximum minus the difference of maximum and minimum. Interquartile range is Q3 minus Q1. Skewness and kurtosis. You can find these two figures are in the range. If we are taking even the range is -2 to +2 or -3 to +3, in both the cases, these two figures are in the ranges, right? So that way, maybe looking at these two also, we can conclude that sales is approximately normally distributed. Coming down, talking about the Shapiro-Wilks test. So the figure is for the significant, the values is 0.018. So it is 0.018, but so this figure is less than 0.05, right? Is it or not?
Yes, ma'am.
Yes, so it is less than 0.5. So the meaning is that we can conclude here that the sales is normally distributed or not? Anyone?
Normally distributed.
Okay. This figure is less than
No,
0.0.
no.
Yes.
Not normally distributed.
Not
It is
normally
not
distributed.
normally distributed, yes. So that means on the basis of the significant value, we can find that significant value is less than 0.05. So that means we do not accept null hypothesis of Shapiro-Wilks. So that is why we can conclude that sales is not normally distributed. Coming down, histogram is a little dicey, I think. It is not explaining us clearly the normality of the variable sales. Looking at the QQ plot, again, you can see many points are deviating to this fitted line. So somewhere it is little dicey to say that the variable sales is perfectly normally distributed, right? Going down, looking at the box plot. Box plot is indicating there is no outlier available in your sales variable. So that way, few of things we have already checked, or few assumptions we have already checked using this explore option of the analyze menu. So that way we have ascertained about the normality and about the significant outliers in the sales variable. Is it fine? May I proceed?
Yes, ma'am.
Yes. Now you can go to the analyze menu. Then in the regression, you need to select linear. You go to the analyze menu, select regression, and then select linear. Done.
Yes, ma'am.
You can click on this linear option. Now you need to, when you will come on the linear dialog box, here you need to shift your dependent variable in the dependent box, independent variable in the independent box. So as we have taken advertisement as independent variable, we can shift it into the independent list or box, and sales in the dependent box. Is it fine? Done. May I go with the next option?
Yes, ma'am.
Okay, you can click on the statistics button. Here you can find it is indicating you the by default or the by default option at the left hand side for the regression coefficient is estimates. So you do not need
Can you
to.
repeat, please? Pardon, ma'am.
From
Can
where,
you
ma'am?
repeat, please?
From where?
Ma'am, this analysis.
Okay. Okay. You need to go to the analyze menu, then regression, then linear. Then okay. Then you can click on linear. In the box, under the dependent box, you need to shift your dependent variable, which is our sales. Independent variable we are going to take as a advertisement. So firstly, I'm shifting the advertisement as it is my first variable. Then sales, I'm shifting to the dependent list. It is done.
Yes, ma'am. Thank you so much.
Most welcome, ma'am. Now you can click on the first tab or the first button with the name statistics. You can click on this. Here, whatever is the by default option at the left hand side and the right hand side, we will go with it. Apart from that, you can check the last box, that is the collinearity diagnostics, and under the residuals you can select the Durbin-Watson. Is it fine? Also, if you want to get the descriptives for your data, also you can check the third box. Is it fine?
Ma'am, can we also check on R squared change?
Sorry.
Can we also take on R squared change?
Up to you, ma'am, if you want. Otherwise, whatever results we will get through all these options, these are suffice to give you, or you suffices for to report in any research study.
Okay.
Because options are many, but whether they are applicable for us or not, it is depending. So whatever are applicable for us, that I've told you, right?
Okay.
Then you can press continue. Yeah, thank you, ma'am. Then you can press continue. You can come to the save button. Done. Here under the distances, you need to check the Cook's box. This is only you need to check here. Done.
Yes, ma'am.
Yes. Then you can press continue. I think in options we do not. Yes, in options we do not need to check or touch anything. Whatever is by default, it is fine. You can press continue. Done. It is all you need to do here, and then you can press OK. So may I?
Yes, ma'am.
Yes. So once you will press OK, you will get all the output of regression in the output window. The first table is about the descriptive statistics, right? It is talking about the sales and advertisement, right? Here you can find, Namaste Bhaiya. So here you can find the mean sales of the company is 10.08 The mean advertisement expenditure of the company is 3.508. The standard deviation of the sales and advertisement of the sales is given here for both the variable. Their figures or the observations are 30, 30. This is the meaning of your table number 1. Is it fine? Table 1 is clear?
Yes, ma'am.
Yes. Coming down, talking about the correlation. So for regression, we always need to find the correlation between the variables. So if you are making your notes, you can write, generally correlation is the precursor for the regression. Means priorly you need to check correlation between the two variables or whatever number of variables you are considering. For the regression, you need to first check correlation among or between them, right? So SPSS always give you the results of correlation. So here we can find here that when we talk about advertisement and sales, so the correlation is coming as 0.862. So this 0.862 means 86.2% relationship is there between the sales and advertisement, and this is a quite good correlation between these two figures, right? Coming down, so here it is showing the method was which we have, although I think I forgot to tell you, I'll again go to the linear. You can find here the method by default is enter, and it is suggestive method. We always need to go with this enter method only, right? So it is showing us that we have chosen the enter method for the entering of the variables in these two boxes, the dependent and independent box. Coming down, talking about the model summary, it is very important part of your particular this regression. You need to see R is the correlation figure. It is same which we have got here. That is 0.862. You can find here, right? So the same figure we are getting here. So the R is the coefficient of correlation figure. Then talking about R square. R square is the square of this R. So R square indicates as the coefficient of determination. It is important for us to report this figure. It is indicating the value is 0.743. So it is indicating that around 74.3% variance in dependent variable is explained by independent variable. It is indicating that how much variance your dependent variable is causing in your independent, how much variance in your dependent variable is caused by your independent variable. So it is around 74.3%. Adjusted R square, generally it is reported in case of multiple regression. So as our case is the simple linear regression, because we are having only one independent variable, so we do not need to report this. Always this figure would be, means this always adjusted square would be either equal to your R square, or it would be always less than to your R square. It can never be a greater than figure to your R square, right? Coming down, talking about the ANOVA, as I have already told you people this thing, that in case of regression, we always get the ANOVA table. So it is indicating, this particular table is indicating the F figure is 81.027 and the significant value is 0.000. So this is indicating this is less than 0.05. So this way we can conclude that variables are linearly related, or also I can say that the model is a good fit. This would be the interpretation of this ANOVA table. Going down, talking about the coefficient table, here you can find in the coefficient table, yes, you can see the constant mean, if just a minute, I'm coming here in the word file. Yes, so suppose line I have already told you, the regression line is generally y is equals to a plus vx, right? So meaning of y is, it is our dependent variable, so I can write sales is equals a plus b into advertisement expenditure, right? So this would be the regression line. Here we need to find the value of a and value of b, so that we are finding here in this output. So here you can see in the coefficient table, the constant means this is your a, it is 5.804, and the b, that is coefficient of advertisement, it is 1.220. But whether these two figures are significant or not, that we can ascertain using the T and its significant value, right? So here you can find that the significant value for both constant and the advertisement coefficient is 0.000, means it is less than 0.05. So that way we can conclude that constant, that is A, that is intercept, and the coefficient of advertisement both are significant, means they are significantly contributing to your dependent variable, right? This is the VIF figure. It can be in between 0 to 10. So the one is acceptable value. It is indicating what? I have explained you this thing in the assumption part. As you can see this, it is indicating you VIF, there should be absence of multicollinearity in the data, means your variables are not highly correlated, means not more than 0.9 we are getting, and that we can check using the value of correlation also, right? So this way, this particular thing is indicating you that this you do not need to report, and this is also you do not need to report. Only whatever you need to report that I have explained you, right? Durbin Watson, I forgot to tell you that you can see in the model summary, this figure should be in between, generally it should be in between 1.5 to 2, but maybe the case as we are having the less data, that is why we are not getting a good figure. But generally, I have told you the threshold value should be around 1.5 to 2, right? So that way, Darwin Watson will help you out to say this thing that the residuals are independent to each other. Means your residuals should also not be correlated to each other. This is again the assumption of the assumption of the regression. So now I'm coming here and formulating our equation, and our coefficient values were 5.804. Yes. So here we can come and write sales is equal to 5.804 plus 1.22 into advertisement, right? Is it fine? Now if I will put any of the figure for the advertisement, that I can multiply by 1.22, that I'll add in the 5.804, and that way we can interpret, or that way we can predict the value of sales. So that way regression helps us to predict or do the forecasting of your dependent variable. Is it fine, everyone?
Yes, ma'am.
Any doubt so far?
Ma'am,
Yes.
ma'am, here in the model summary, it is written R square and adjusted R square. Is there any meaning of this? I mean, you need to indicate it indicates something. You need to tell
Yes,
here.
I think I have already explained you the meaning, ma'am. And I told you in case of simple linear regression, we need to report R square. If you are going for multiple regression, in that case, we can report adjusted R square. So R square is indicating you the variance in the dependent variable, which is explained by your independent variable. So how much variance independent variable is explaining, that percent you can say this is explanation of your R square.
Okay.
Okay. Any other doubt? Yes. Anything else you want to ask me regarding regression or correlation? If not, so I think this is all from my side for the day. And I think we have now reached at the end of this FDP. Yes, Sugandha ma'am.
Ma'am, we while analyzing, we take down something said like cook something.
Yes, Cook's distance.
Cook's distance. Ma'am,
Yes.
what was that and why did we take that?
Cook's distance, I think I have already explained you the meaning. In Cook's distance, we are using for finding whether the particular observation is influential or not. So I think if you have applied the regression along with me, you will get its output in the data view.
Yes, ma'am, we have the output.
So you need to check there whatever the value you are getting. Generally, it is 4 by n. 4 by n is the general formula. 4 by n meaning is n is the sample size. If you will divide 4 by 30, so you will get a figure. So whatever values you are getting here for Cook's distance, they should be less than that particular value. To check whether any particular observation is influential. Influential means it is highly impacting your model or not. If it is highly impacting, in that case, you can drop it and then you can again apply the regression.
So like ma'am, in Cook's distance, we have minimum, maximum, mean, and standard deviation. So which figure should we look at? Ma'am, the table residual statistics in that
You need to check, madam. I said you need to check the main file. You need to check the data view of your file. In the data view of your file, you will get the Cook's column. One more column would be added there.
Yes, ma'am. Okay,
so that right. Okay. Yes, you need to check there.
Okay,
fine.
Thank you. Thank you.
Yes, thank you. Anything else you want to ask me? No? Okay, so I think this is all from my side for this FDP. Thank you so much everyone for listening me patiently and bearing me for these 7 days and working along with me. I hope this FDP has helped you out to understand how you can perform various statistical tests using the SPSS. I tried to explain you the things in my way. Maybe these things can be help you out to perform your research study, right? So thank you everyone. Before ending, I want to say or express my gratitude towards the RFI for giving me opportunity for conducting this FDP. So thank you so much, Ajay sir, Saurabh sir, and every member of RFI. Please, thank you so much for helping or giving me this opportunity to conduct this FDP. Okay. So anyone here from the RFI is available? Okay, so before ending, can I ask you people to please switch on your camera so that it is the last day and we can capture the pics?
Ma'am, on behalf of the participants, ma'am, I also want to thank you very much. Thanks a lot for this wonderful FDP. Though many of us were not from the background of statistics, but even then we are very much benefited. Thank you so much.
Thank you so much, Pratima ma'am, for your kind words. I know sometimes it is a little problematic for us to understand the things because those who are not from the statistics background, I can understand that can be little trickier for them because this is totally technical terms. There are so many technical terms there are available in statistics and might be possible if people have not got clarity also. Although I tried a lot, but I think the sessions are little 1.5 hours or something, and it is after this particular my colleges and all college time. After my college time, I am conducting these things. So maybe possible somewhere I have not done the justice also. So apologizing for the same. And at the same time, I want to say I tried a lot. I tried my best to explain you the things also. But still, if some of the problems are there or some doubts, maybe I have not answered you or something like that, you can always ping me. Might be possible I will not give you a time or the time you are asking me, but later or sooner I will give you the answers. Right?
But you explained everything in very wonderful way.
Thank you, Pratima ma'am. Thank you, everyone. Yes, thank you so much. Thank you.
Thank you.
Yes. So I think we can, yes, thank you so much, everyone, for sharing your screen with me and switching on your cameras. I have captured all of you. Thank you so much.
Thank you, ma'am.
Thank you, Pratima ma'am. Yes, thank you. Thank you, everyone.
It's wonderful session and FDP.
Thank you so much. Thank you so much, ma'am. Thank you. Thank you. My number is already there. My number is already there in the WhatsApp group because I'm sharing these what data sheets and everything. So you can save my number. It is already there.
And ma'am, will we get the certificate for joining this FDP?
I think, ma'am, as per the rule, RFI always provide certificates, right? But I think I'm not the right person to answer that because I'm only here to delivering the sessions. So the right person would be the RFI persons, right? They can answer you in a better way.
Okay, fine, ma'am.
Thank you, ma'am. So thank you everyone. Hope to meet you soon, maybe in future or somewhere, maybe in physical mode or somewhere we will meet.
I mean, which
right?
college you are?
I am in Prestige, ma'am. Prestige Institute of Management and Research, Indore.
Okay, Prestige.
Yes.